Language of set. Set, the use of word set as a formal mathematical term, was introduced in 1827 by George Cantor. Set is a collection of elements. For instance, if C is the set of all countries that are currently in the United Nations, then the United States is an element of C. There are two ways to specify a set roster notation and set builder notation. This is the example of set. So, if we just write 1, 2, 3, and 4, that's not a set unless we put a bracket on the right side. That's an example of set. Set roster notation. If S is a set, the notation means that X is an element of S. And if X is not in the element of S, the notation means that X is not element of S. A set may be specified using the set roster notation by writing all its elements between braces. Example of set roster notation. Number 1. Denotes the set whose elements are 1, 2, and 3. Number 2. Denotes the set of all integers from 1 to 100. This notation is used to describe a very large set. Number 3. Denotes the set of all positive integers. This notation describes as infinite set. The symbol is called ellipsis and is read and so forth. Axiom of extension says that a set is completely determined by what its elements are not the order in which they might be listed, or the fact that some elements might be listed more than once. So this is the example of axiom of extension. We have the set A, 1, 2, 2, 3, 3, 4. And set B is 2, 2, 1, 1, 3, and 4. And set C is 3, 4, 2, and 1. In axiom of extension says that a set completely determined by what its elements are not the order in which they might be listed, or the fact that some elements might be listed more than once. So as you can see, these three sets A, B, and C has the same elements. They are just different the way the elements are listed. Set builder notation. Set builder notation. Let S denote a set and let X be a property that elements of S may or may not satisfy. We can define a new set to be the set of all elements X in S such as P and X is true. Subset. If A and B are set, then A is called a subset of B. Written A is a subset of B. If and only if ever element of A is also an element of B. Symbolically means that for all element X, if X is an element of A, then X is an element of B. The phrases A is contained in B and B contains A are alternatively ways to saying that A is a subset of B. This is an example of subset. So if A and B are set, then A is called a subset of B, written as A is subset of B. If and only if every element of A is also present or element of B. So all the elements of A are present in the elements of B. So A is a subset of B. Proper subset. Let A and B be set. A is a proper subset of B if and only if every element of B is in B, but there is at least one element of B that is not in A. This is an example of proper subset. So in a proper subset, let's say A and B a set. A is a proper subset of B if and only if every element of B is in B, but there at least one element of B that is not an element of A. So we have B, all the elements of set A in B. These elements are all in set B. Set A are all in set B. And there is one element in set B that are not in set A, which is the 9. So this is the example of proper subset in the language of sets.